Use mu of x equals x squared for the inexact equation and solve. All right, so we solved this in the explanation a couple times, but we never actually found f of x comma y. And so we know this is a inexact equation. We multiply by x squared, we'll get an exact equation. So we'll go ahead and do that. So we get 3x squared y plus xy squared plus x cubed plus x squared y prime equals 0. And then, right, we have m of x comma y and Neptune of x comma y. Right, and so now we want to do our thing where we want to find f of x comma y equals c. All right, we have m Mars of x comma y plus Neptune of x comma y prime equals 0. And right, so the way we go backwards is we're going to do m to f with an integral with respect to x, and Neptune to f as an integral with respect to y. All right, so just to finish off this problem, let's see. So we have f of x comma y is equal to definite integral of m of x comma y dx. Okay, well that's a definite integral of 3x squared y plus xy squared. So 3x squared y plus xy squared dx. All right, well, let's see that. Let's see the 3 and the x squared. So the 3 will go into the exponent, and x squared becomes x cubed. And the y stays as it is. Then we got plus x squared y. So our xy squared, the x squared will go to power 2, and it will have a factor of 1/2 to balance it out. This is plus 1/2 x squared y squared. And then remember, I might need this function h of y in case some stuff disappeared, going from f to Mars with the partial derivative with respect to x. All right, now going the other direction, we have f of x comma y equals, that also has to be equal to indefinite integral of Neptune of x comma y dy. Well, that's indefinite integral of x cubed plus x squared y, x cubed plus x squared y dy. All right, well, let's see, x cubed will become x cubed y, and then x squared y, the y turns into y squared, and a 1/2 pops out to balance the power. So I get 1/2 x squared y squared. Right, and I might also need this g of x function in case anything disappeared, going from f to Neptune with the partial derivative with respect to y. Right, but now the next step here, so I found these two ways to get f, and they both have to agree with each other. And so this one, the top one has x cubed y, the bottom one has x cubed y. The top one is 1/2 x squared y squared, the bottom one has 1/2 x squared y squared. And that's actually everything. So this h of y here ended up not being necessary, it's just equal to 0. And this g of x was also not necessary, it's just equal to 0. So this function, f of x comma y, is just x cubed y plus 1/2 x squared y squared equals a constant.